All right, so we are starting lesson 5-2 today about similar polygons. So similar polygons are polygons that have the same shape but different sizes. So a square and a rectangle are not similar polygons because they're not the same shape. Throughout the lesson and throughout the rest of this chapter, we're going to be looking at scale factors, and it's the numerical ratio comparing the lengths of corresponding sides of similar figures. So to be more specific about what that means about same shape but different sizes, two polygons are similar if and only if their corresponding angles are congruent. So here we would see B and B prime because they both have those two arches in them. So we know that those two are congruent. But their sides, their corresponding sides, so we would say CD and C prime D prime, they are proportional. So angles have to be exactly the same measure, but sides are going to be proportional. So our first example, it says determine whether each pair of figures is similar, and then we have to justify our answer. So both of these are isosceles triangles. We can see that, and we know that because of these two little tick marks or dashes through each of the sides. So the angle that is between both of those sides, that's our vertex angle. So K is my vertex angle and P is my vertex angle. And if these two triangles are similar, then those angle measures must be the same. So the measure of angle K needs to equal the measure of angle P. The measure of angle K is 40 degrees. The measure of angle P is 50 degrees. And so we can see that 40 is not equal to 50. So we know that these are not similar. And our justification is that work we just did there. So let's take a look at part B. Determine whether each pair of figures is similar. So in order to do this one, they gave us angles and side measures. So let's start with the angles first, because typically that's easier. So S, if we look at them, they are oriented the same way. So B would go with S, C would go with T, and A should be the same as R. So we see that B and S are both the same, but now we have to find the measure of angle C. So a triangle is 180 degrees total. So if we take 180 minus 80 minus 60, we find out that C is 40 degrees, which does match angle T. And so if those two are the same, we know that A and R have to be equal, and 180 minus 80 is 100, 100 minus 40, that does leave us with 60 here. So therefore we do know that the angles are congruent. So that's half our battle. So angles congruent, check. The second thing we have to look at is, are the sides proportional? So I find it very helpful that if we put those little arcs in each of the angles, that now I can say, okay, the side that is between the one arc and the two arcs, so between B and C, corresponds to the same over here. So 7 and 5.25. So I'm going to go ahead and set up our proportion. Since we have three sides, I'm going to go ahead and set up three different proportions. So it's going to be 7 over 5.25 equals, and I said three proportions, three ratios. Then I'm going to do 8 over 6, and notice how I'm always putting triangle ABC up top and triangle RST in the bottom. So 8 over 6, and our last one should be 5.2 over 3.9. Now if we look at all three of these ratios, they do not look the same at all. So what we're going to do is just simplify each of them. So just type 7 divided by 5.2 in your calculator and see what you get. So when you do that, you end up getting 1.3 repeating. So now type 8 divided by 6 in your calculator. If you do that, you get 1.3 repeating. And I hope you guys are actually doing this, checking on your calculator. And finally, if we type 5.2 divided by 3.9, we get 1.3 repeating again. So that tells us that all of those three sides are proportional to each other. So therefore, we can write our similarity statement. So a similarity statement is just how we can say that these triangles are similar. So the first triangle you write, you can write those letters in any order. I'm just going to do triangle A, B, C. The symbol for similar is just that little tilde. Now, since I did A, then B, then C, I did the angle with 3 arcs first, the one with 1 arc second, and then one with 2 arcs third. I know I sort of went out of order there. So I'm going to do 3 first, 1 second, and 2 thirds. So if I did A to B to C, I have to do triangle RST. And that's my similarity statement. And just to go on a little tangent, from the similarity statement, we are then able to tell which angles and sides are equal. So since letter A comes first, A and R, those are the angles that correspond to each other. B comes second and S comes second, so B and S are the ones that go together. And C comes third, T comes third, so that means angles C and T are the corresponding angles. All right, so now take a moment, try the 2 your turns, so you can pause the video and then come back and we can go over those 2. All right, so for the first your turn, we have to determine whether these pairs are similar. We can already tell, hey, that since that angle is 76, I know that this is 76. And now we can find that vertex angle by taking 180 minus 76 minus 76. And that is 28 for the vertex angle of X. Since triangle RTW is also isosceles, we can take 180 minus 28 and then divide that in half because R and T are our base angles and they are both congruent, and we find out that each angle is 76 degrees. So if we look, all 3 angles of both triangles are congruent. So we know it's yes. We can cross off C. Now we just have to figure out, okay, or actually, I guess I shouldn't say yes. We still have to figure out if the sides are proportional. I almost forgot about that. So let's go back and check out these sides. Let's see if they are proportional. So both of these sides are the same, so we're going to write 16.5 there. I'm going to write 11 there. So I really only have to set up 2 proportions here because 2 of the sides are exactly the same. So I'm going to do the small one over the big one. So I'm going to do 11 over 16.5. Notice I put the sides that were corresponding together. And then I'm going to do 5 over 7.5. So when you go through and simplify both of these, we get 0.6 is equal to 0.6. All right, so it still did work out to be yes because all the angles are congruent and our sides are proportional. But now we're stuck between 2 answer choices. If they do A to X to E, because notice how both of them are the same there. Let me erase all this stuff on these triangles I made extra so it's a little bit easier to see. So if they did A, I'm going to put a 1 beside that. They did X second, so I'm going to put a 2, and they put E third, so I'm going to put a 3. So they did a base angle, vertex in the middle, and another base angle. So the vertex angle needs to be in the middle. So W has to be in the middle. So if I look at this, that one has an R in the middle, that one has a W in the middle. So answer B is our correct answer. All right, so hopefully you got B for the first one. For letter B, we still have to check both of these. So again, I find it a little bit easier to check our angles first. So if we look at triangle RST, we take 180 minus 110 minus 40, we get 30 degrees. Now if you look at the other triangle, AGN, the smaller one, we do have a 30-degree angle, but then we have a 35-degree angle. And that last angle, if we take 180 minus 35 minus 30, it's 115 degrees. So we can see already that our angles are not equal to each other at all. So we can already say, nope, those triangles are not similar. All right, moving on to the next example. It says, an architect prepared a 12-inch model of a skyscraper to look like a real 1,100-foot building. what is the scale factor of the model compared to the real building? So when we are writing a scale factor, we're actually just going to write a ratio. And something that is super important anytime we write a ratio is that the units have to be the same. And the reason I say that is because we have inches and feet, so we have to convert either inches to feet or feet to inches. And I will tell you, it is exactly the same. I'm going to go ahead and do everything in feet because I see 12 inches there, and 12 inches is already a foot, so that one's really easy to convert to. So it says, we just have to be careful now. It says scale factor of model to real building. So we have to go back, make sure our model comes first, and then our real building is in the denominator. So I'm going to go ahead and write 12 inches over 1,100 feet. But remember, we need to convert this. So 12 inches is really 1 foot. And the 1,100, I don't have to change because it's already in feet. So that's our scale factor already. 1 to 1,100. And the scale factor, we're all done with that one. So now I'll take a moment, try the your turn, and then come back and double check your answer. All right, so for this one, the space shuttle is about 122 feet in length. The Science Club plans to make a model of the space shuttle with a length of 24 inches. What is the scale factor of the model compared to the real space shuttle? So since I changed everything to feet last time, I'm going to go ahead and change everything to inches this time. And I will say it really doesn't matter. And maybe I will just do both so that way everyone can see that it does not matter which one we do. I will do inches over here, and I will do feet on the right side. So if I'm converting everything to inches, let's see how do they want us to set this up. They want the scale factor of the model to the real. So model in the numerator, real in the denominator. I'm going to go ahead and write that over here so that we don't forget. Remember, you don't have to do both. I'm just showing you both. That way you can see it. It does not make a difference. So the model is going to be 24 inches. And the real one is 122 feet. So if I'm converting to inches here, my 24 inches gets to stay. And my 122 feet, I need to multiply 122 times 12 because there's 12 inches in a foot. And we get 1,464 inches. Now, if we simplify that, we get 1 over 61. So that means the model is 1/61 of the actual building. And I should get the same answer if I convert everything to feet. So let's go ahead and do this one. I'm going to get 24 inches over 122 feet. So 24 inches is 2 feet over the 122 feet. So if I simplify that, I still get 1 over 61. So that must be right. Should be A. And if we look, our answer is A. So great job if you got A on that. Notice how that answer they did put as an option. So if you do forget to convert your units, and if it's multiple choice, they usually will give you that option. All right, moving on to example 3, our last example for this lesson. We have a couple things to do in this problem. So they gave us 2 pentagons, and it says the 2 polygons are similar. So they are telling us that, which means we know corresponding angles are congruent, and we know that their sides are all proportional. We have to write a similarity statement, and then we have to find x, y, just x and y, and uv for this problem. So our similarity statement, I'm going to go ahead and start with a larger one because I like to start with A, B, C. And if we notice, I'm just going to go ahead and do them in order. I'm going to start with A and go A to B to C to D to E. So I went 1 arc to 2 arcs to 3 arcs to 4 arcs to 5 arcs. So Similarity statement, triangle, A, B, C. Oh my gosh, I wrote triangle there. It's not a triangle, so let me start that over. This is a pentagon, so I'm going to do pentagon, A, B, C, D, E, is similar, remember our little tilde there, to pentagon. Now, since I did 1 arc, 2, 3, 4, 5 arcs, I have to do in that same order. So that's going to be R, S, T, U, and V. All right, so similarity statement, done. Now we have to find X, Y, and once we find Y, then we can find UV. So I'm going to go ahead and start. I want to find X, so I'm going to go ahead and put X in the numerator. So X over something is going to equal two other somethings over one another. So I need to look a little bit ahead here. So I could do X over 8, right? So that means I did the right side over the base. Well, then I have to do the right side, which is 3, but then I have to do it over this base, but that base is y plus 1. So if we look at this fraction, now I have two unknown values, and I can't really solve this. So that's why we need to look a little bit ahead. So I can still do my X, and I can still do my 3, but let's see if there's another side that we know both of the sides of. So if I look, I know that top left side. Oh, I also know that top left side. So those are going to be the two that we use. So I'm going to do X over 6 is equal to 3 over 4. So now we can just cross multiply like normal. So I get 18 is equal to 4x. And then if I simplify this, divide both sides by 4, I get x is equal to 4.5. So we now have our x value of 4.5. X is 4.5, so part of it done. All right, so now let's find our y, because if I find y, then we know what uv is. So we're going to set this up very similarly. This one I'm going to set up just slightly different. So the last time I used the large pentagon all on this side, and then I did the small one on this side. I'm going to do it a little bit different because remember I said yesterday or in lesson 5.1, there's 4 different ways that you can write the same proportion. And after you cross multiply that very first step, all 4 methods you should get that same first step. So in this one, since I did x over 6, I'm going to start with my y plus 1. But now in this denominator, I'm going to put the side that corresponds to y plus 1. And the side that corresponds to that in my other figure is 8. And now I could use 3 and 4.5, but if I made a mistake on x, finding x is 4.5, then I know I'm going to get y incorrect. So just to be sure, I'm going to go ahead and use my 4 and my 6 again. So since I did y plus 1, which is my small figure in the numerator, I need to continue and put my small figure in the numerator over 6, which is the side length from my large figure. So now again, we have to cross multiply. So we get 8 times 4 equals 6 times y plus 1. So 8 times 4 is 32. And then if I distribute 6y plus 6, I'm going to subtract 6 from both sides, so I get 6y is equal to 26. And then if I divide 26 by 6, I end up getting 4.3. So that means y is 4.3. So I found x, I found y, and now we have to find uv. So to find uv, uv is y plus 1, and we know that y is 4.3 plus 1, so therefore we know that uv is equal to 5.3, whatever those units may be. All right, finally, A is all done. So we wrote our similarity statement, we found x, we found y, and we found uv. So let's move on to part B. Part B doesn't ask us to do too much here. So part B says the two polygons are similar, exact same polygons. We have to find the scale factor. Now for the scale factor, again, we really need to pay attention. They want A, B, C, D, E first, 2, R, S, T, U, V second. So whatever comes first must be in the numerator. So I'm going to go ahead and write myself that little reminder. A, B, C, D, E, all over R, S, T, U, V. All right, so A, B, C, D, E first. All I have to do is just pick one of those sides. I could pick every single side that we know the measurement to, but since they told us they're similar, we already know that their proportions are all going to be the same. So just pick one side that we know for each figure. So I'm going to do AB and RS. So AB is my big pentagon, so I'm going to put 6 in the numerator and 4 in the denominator. So just like every fraction, we always need to simplify. So we get 3 over 2, and that's our scale factor. It was that simple. All right, so take a moment, try the your turn. You have A, B, and C. They're not asking for quite as much in that problem, so it's the last one for the day. So go ahead, pause the video, try the your turn on your own, and then come back and watch the video. All right. For part A of the your turn, it says the two polygons are similar, so we know that we have to write a similarity statement. So this one is multiple choice, so they already did TRAP. If it were me, I probably would have started with the 1 arc, then the 2, then the 3, then the 4, but they have TRAP, so that's what we're going to go with. So T was the one with the 4, R also has 4, and then we get 2, and then we get 1. So this one's a little bit different because of how these shapes, or how the angles are noted here. But that's fine, we can still go through here. So for this other one, and I'm really looking at this problem, and I'm thinking that they really wanted to put a 3 there. Pretty sure they just wanted 3 lines. I'm going to go ahead and put 3 lines, even though it makes no difference. Because since they did TRAP, that means I need to start with Z, O, L, D, which would be my 4. And I just numbered this one as by how they went. So I'm going to do the same over here. So they went T first. Oh my goodness, I keep writing the letter. They did T first, R second. They did A third, and P fourth. So notice how my numbers go in order. TRAP, ZOLD. So therefore, D is the correct answer for the similarity statement. Sorry, I think I made that much more complicated than it should have been. But look, yay, we're all right. All right, moving on to part B, where we have to find the value of A. They told us they're similar, so that's great. We can go ahead and set up our proportions without having to check everything first. So let's find A. A is the right side, so I know I'm going to use 4. So I'm going to do A over 4 equals. Now let's find a side that we know both of them. Oh, we know the bottom of each. So I'm going to do 3 over 5. So if we cross multiply, we get 12 equals 5A. And then if we divide 12 by 5, we get A is equal to 2.4. Perfect. That one matches. Let's move on to part C. Now they're asking us to find B. So I like to put whatever variable I'm trying to find in the first part of my fraction. So that's why you'll always see that. So I'm going to do B minus 6. So that's the top. I'm going to put it over the top of my other one. So that's over 2. Equals again. I know the bottom of both, so let's use those. So B minus 6 over 2 is equal to 3 over 5. So again, cross multiply. 2 times 3 is 6. I'm going to go ahead and, I'll go ahead and write this out. So 6 is equal to 5b minus 30. And then I'm going to add 30 to both sides. So 5b is equal to 36. And then if I divide both sides by 5, I get 7.2. And look at that. It is our answer.